Hello, folks. All right. Well, we pretty much handled our sessions on going through and parsing the languages that we wanted to work with. So we looked at the ideas of context-free grammars and building a parse tree, and whether we're going through and doing this top-down or bottom-up, and whatever system we used, we looked at the idea of creating some kind of a parsing to figure out if the sequence of tokens is structurally valid for the language. But as we've said, there's a lot of things that simply doesn't resolve, that simply doesn't check. And we've been going through and doing a lot of work with Yak recently to see if we could come up with ways to go through and check things like, have variables been declared before they were used? Do the types of two different things match? So the kinds of things that do require knowledge of the context that a structure is present in. So what I want to do now is just look at a bunch of different handcrafted solutions and ideas to approaching some of those different problems. And then later we'll take a look at more automated approaches for this and some of the issues that come along with that. So that's kind of where I want to go for this session. So again, lots of things that context-free grammars and our basic parsing can't handle. So for variables and functions and constants, how do we enforce the idea that they have to be declared before they're used? Or if they don't have to be declared before they're used, then how do we figure out, what they are? Or if we allow a declaration to come later in the program, I'm able to call a function regardless of where it's actually declared in the program. How do I handle something like that? So we want to think about how to approach that. If we get into the ideas of scoping, so if we've got different layers of variable scope, if I see a reference to a variable, how do I ensure which one it is if there's some of them that overlap? So if I've got an X in the global scope and an X in a local scope, and an X in even more local scope, how do I resolve which one to deal with? Or with functions, if I allow nested function definitions, if I can declare one function inside another, how do I ensure that I can actually know which function I'm supposed to call? And how do I know which ones are actually in scope? So identifying and dealing with scoping issues. Type checking and type conversions for that matter. If I've got an expression, how do I ensure that the data types are all correct for the operator that's in use and for one another? If I'm assigning the result of some expression to a variable, how do I make sure that all of the types are appropriate? And if there are places in there where I have to do an implicit type conversion, where are those? If I do something like 3 plus 5.7, does it look at that and go, oh, well, I better carry out a floating point operation, and so first I'll convert the integer to a float. So what do we have to do in terms of type conversions? If we've got a function call, how do we go about checking that the call has the correct number of parameters to pass and in the correct order and with the correct data types? So lots of different things that we want to try and check, and we'll just go through and talk about each of them a little bit in turn. So in terms of the declarations versus use. So the most basic approach is if our language requires that you declare something before you use it. So if you've got a variable, you have to declare it before you use it. Maybe you have to specify a type for it. If you've got a function, you have to declare it before you use it. And so that's the most basic sequence. And in that case, if we're going through the instructions in the program more or less in sequence, then we'll hit the declaration, the definition, before we hit the use for it. And so by the time we see the first use, we can look at it and see if that use is valid based on the definition. And if we see something that we haven't seen a definition for yet or a declaration for yet, then we can say, oh, that's an error. You haven't declared this variable, you haven't defined this function. So that's the most basic approach, and we can do things like maintain a symbol table, as we've done in some of our lab work. Maintain a symbol table, and when we see a declaration, we add it to the symbol table with appropriate information. And when something's used, we look it up in the symbol table to make sure it's being used appropriately. Now, it's possible that our language allows implicit declarations. So the first time you use a variable, it's automatically declared, for instance. So in that case, when we see that first use where we go through and look up the definition of a variable, for instance, in our symbol table and discover that it's not there, at that point we say, okay, well, I'll add it and then proceed based on that. Right? So there are a variety of different things that we can focus on. But if we use this kind of an approach, if we say it's got to be declared before it's used, then we can't achieve this with things like mutually recursive functions. If f calls g and g calls f, then one of them has to be defined first, and it's going to contain a call to something that hasn't been defined yet. So one of the things that's done is say, well, maybe we set up forward declarations, where sometime before the function is used, we can include a declaration that isn't a full declaration of the function, but basically says, it's basically a promise that later in the program, I'm going to give you the full definition of this. Please, compiler, allow this until you see that full definition. And so in that case, the compiler can say, as it's going through, say, okay, well, based on that preliminary declaration you gave me, it looks okay, and then we'll see the full declaration later. And if we don't see the full declaration later, then we throw an error. So we keep track of the things that we're still expecting to see definitions for. So there are a variety of different approaches that we can take. Now, if our language is a little bit more flexible for the programmer and it says you can declare anything anywhere and you can use it before you declare it, then you're saying, well, it's up to the compiler to go off and find the definition somehow regardless of where it is. So again, there's a few approaches. We could take the same sort of idea as we did with forward declarations, is look at the declaration for the use for now and say, well, okay, I'm going to kind of assume that that's an okay use, and I'm going to stick a little flag here and remember that I better see a declaration for this sometime by the end of the program. So I start keeping a list of things in the symbol table, for instance, saying this thing is used in this way. If I don't ever see a declaration for it, it's a problem. If I see a declaration that's incompatible with the way it was used, then it's a problem. So you can use this kind of an idea and you make your pass through the code, and if by the end everything isn't resolved, then you say, oh, no, there's a problem. Or you could go through and say, well, why don't I make two passes through the code? The first pass is just to fill in the symbol table, and then the second pass is to do the full compilation. So by that point, I know the declarations, the definitions for everything. So again, there are a variety of different approaches you can take when you're trying to resolve the context-sensitive problems. Similarly with scoping issues. Right, let's assume for the moment that we're using the nice kind of traditional lexical scopes where if you declare something, you can use it in the rest of the block that it's declared in and in anything that's nested inside that block. So you've got a global scope, and maybe you've got a function scope, and maybe there are loop scopes or block scopes within that. But you've got this nested layer. And even if you allow functions declared inside functions, you've still got this nesting taking place where something's available, all the layers of nesting that are included inside the current scope. So one of the things we could do, if we want to be able to handle issues like I see a variable x, which x is it referring to? Right? I want to look at the innermost scope first and see if an x is there. If not, I'll look a next layer out, and if not, I'll look the next layer out. And if we get all the way to the global scope and we still don't see it, then we can flag it as an error. But that way we guarantee that we're using the right one. So perhaps what we do is give each scope a unique identifier. Whatever you want the identifier to be, you give every scope a unique identifier. And when something gets declared, you say, okay, well, here's my record for it in the symbol table, and you add one more column that's the scope in which it was declared. Now, as you're going through processing the code, you keep track of what scope you're in at the moment. So every time you enter a new block, a new scope, you're saying, oh, okay, I've got this additional scope that I'm in. So maybe you do something like keep a stack of these things. At first you're in the global scope, and if you go from there into a function, then you push a function, the right function scope on top of that. And if you go from there into a loop, then you might push the scope for that on top of that. And so the stack has this record of all of the scopes that are currently active with the most recent ones on top. So when you see a reference to a variable or to a function or to a whatever, you start going through the stack from the top down, looking for the most recent definition of it within the active scopes. Right? And that way, again, you can solve the issue, solve the problem that you're trying to deal with here. Now, another possibility is dynamic scope, where rather than basing things on these nested layers of scoping, we say, well, if a variable is declared inside a function, and that function calls another function, then the variable is visible in that one too. So the call sequence determines which variables you can see or which parameters you can see. So in this case, then it's a little trickier to go through and say, well, geez, how do I keep track of what's accessible, because my compiler doesn't know what the call sequence is going to be. So in this case, it might amount to having your compiler generate code to maintain a bunch of different runtime stacks, one for each of the different item names, one for each of the different identifiers used in the code. So have a stack for X's, a stack for Y's, and whatnot. And as execution is happening, when you see a definition for X, you push it on top of the stack for X's. Right? So if I'm inside a function that defines X, I push a new X, and when that function ends, I pop that X off. Or if I enter a block and define X in that block, when I leave that block, I pop X off. So we go through and we've got this stack of which X's are live right now, and that's maintained at runtime instead of at compile time, which means that the compiler's got to generate the code to the runtime code to maintain these different stacks. Right? So there's all sorts of different issues that we can approach in different ways. Type checking is obviously one of the ones that we've focused on a fair bit, where we're going through and saying, well, okay, if I've got a bunch of different values in an expression, I want to make sure that the data types for those values are compatible with one another for the operation that we're using. So we need to know what data types things have and what data types are valid, and when we should try and convert back and forth between them. So if we've got one of the declare before use ideas, then maybe we can expect that we will have known this thing exists or is supposed to exist, and depending on the language, the declarations might include a specification saying you have to give a type for it. But whatever the situation is, when we see an actual use, we have to compare the actual type for the thing at that point with the types that we were expecting, the types that were valid. And again, if we've got multiple arguments and an operator involved, then we have to make sure that the types are compatible with one another for that operator. If the types aren't exactly what we were expecting, then maybe we also have to say, well, gee, is there a reasonable implicit conversion I could make? So if I've got a spot where I was expecting a real number and I was given an integer, do I do an implicit conversion and just say, okay, well, instead of treating it as the integer 3, we'll treat it as the real number 3.0. So again, we need to be aware of what we'll do or what we can do to handle type checking issues. And type checking in particular, we're going to go through and spend an entire session on next time around. So we will come back to this one. When you see a function call in the code, right, as you're going through and you've parsed it out and you've identified this thing is a function call, and we've used our scoping resolution to figure out which function was being called. Again, we have to deal with the, is it declared before used, or do we have a declare anywhere? So assuming we've dealt with that problem in the same way as we did with variables or constants or whatever other symbols we were dealing with. And again, dealing with the scoping issues, if we're allowing nested function definitions, we've got the same issues to deal with there in terms of keeping track of which scope are we in now and which definitions should be visible. After we've got all of that resolved, we still have to figure out if the actual call has the correct number of parameters with the correct data types compared to what we're expecting. So we want to be able to look back at the definition for the function and say, well, how many operands did it expect, and what data types were they in what order? and then we can match that up with the actual data types provided. Dealing with optional parameters. If you've got a function that has a bunch of optional parameters with default values, then again, as we're going through and parsing this, we have to say, okay, well, if I see a call to this function that's only got the first 2 parameters, then I have to insert the optional values after that. But again, we're going through and checking data types, right? We're checking that we've got the correct values. We're checking to see that we got what we expected. So this is what we'll come back and we'll kind of blend this in with the type checking when we come back here. If we've got a function that takes a variadic function, something that takes any number of parameters at all, how do we deal with that in terms of parsing? Right? So how do we identify where the parameter list begins and ends? So presumably that's something that's dealt with syntactically. But it's going to have to be possible for the generated code to know how many parameters that function was actually passed. So this is something we'll come back and deal with in an implementation idea, but maybe we're going to be going ahead and doing something like, well, let's take the parameters and push them on a stack someplace from right to left so that the first parameter is on top, and then on top of all of them push a count of how many of them there are. So once the function actually has to run, it can say, oh, well, I'll look at that first value and it says I've got 4 more parameters coming, so I know where they are, or I can find where they are. Right? So there are just a ton of different aspects of the code that we're going to have to deal with, far beyond just the straight syntactic parsing of it. And so we'll come back and address a lot of these things in the code generation sections. Obviously, we're addressing a lot of them as we go through the different labs and adding different forms of context-sensitive checking to Yak as we go through and play with that. But these are all issues that we want to think through fairly carefully. All right, next time around, we will talk about type checking in particular.